Welcome back, friends. Let's see one more question which is based on network theory. Question number 13. We haven't done 11th question. We will do it once we complete this 13th question. Question number 13. A symmetrical square wave of 50% duty cycle. 50% duty cycle has amplitudes plus or minus 15 volts and time period t is equal to 0.4 pi milliseconds. 0.4 pi milliseconds. This square wave is applied to a series RLC circuit of R is equal to 5 ohm, L is equal to 10 millihenry, C is equal to 4 microfarad. Then the amplitude of 5000 radians per second component of capacitor voltage is dash. So this is the circuit, series RLC circuit. For this circuit, they have given V of t, which is a square wave. Then they want to calculate how much is the voltage amplitude across the capacitor. Okay. %, duty cycle, that means on state, half state has to be same. So for that we know, we have seen till now the square waves are all 50% duty cycle only. So it is having time period is equal to t is equal to 0.4 pi millisecond. So from this, can you write what is the omega naught value? That is 2 pi by t. So 2 pi by 0.4 pi into 10 power minus 3. So finally this is going to be 5000 radians per second. 5000 radians per second. So this square wave is applied to a series RLC circuit with this one, then the amplitude of 5000 radians per second voltage, capacitor voltage. That means they are simply asking fundamental component of capacitor voltage. I already told you, to find the fundamental component of capacitor voltage, the input must be fundamental component of voltage. I already told you, if the input is fundamental component, the output is also going to be the fundamental component. That means whatever the frequency you require as an output, that frequency we have to consider as a input. So first we have to find out what is the first harmonic component or fundamental harmonic component of V of t. So here, listen. It is a symmetrical square wave. If it is a symmetrical square wave, then let's assume it is a even or odd, whatever it is. I am assuming even. Okay, let even square wave. Even square wave. How it is going to look like even square wave? This is what it is. So what is the positive amplitude? Plus 15, negative amplitude minus 15, minus 15. So this is a square wave. For this square wave, we are having only an, which is 2 into maximum value minus minimum value, that is minus 15 by n pi. So finally 60 pi by 60 by n pi, 60 by n pi. This is what the amplitude. Now what is the fundamental harmonic component of V of t? Fundamental component of V of t. Why we are finding out fundamental component? Because they are asking 5000 radians per second component. That itself is nothing but the fundamental harmonic component. So what is the fundamental component of V of t? That is 60 by pi, 60 by pi cos 5000 t, 5000 t. So this is what it is, the fundamental component. So if it is a fundamental component, now we require to find out Vc of t. So for that, what we do? First we have to draw the phasor domain. In the phasor domain, what is V of t? 60 by pi at an angle 0. At an angle 0. Next, resistor is same as resistor. How much? 5 ohm. Next, j omega L, j omega 5000 into 10 millihenry, 10 millihenry. So that is 10 into 10 power minus 3. So finally how much it is going to be? J50. J50. Next, capacitor is there. Minus 1 by minus j by omega c. Omega c. Minus j by omega value 5000. C value, that is 4 microfarad. 4 into 10 power minus 6. This is also becomes minus J50. Minus J50 ohm, minus J50. So this is what we got. And we require to find out this Vc, fundamental component of Vc. So simply, if I find out the current through it, I is equal to 60 by pi at an angle 0 degrees by 5 ohm plus J50 minus J50. 50 get cancelled. Finally 60 by 5, that is 12 by pi at an angle 0 degrees. This is what the current we got. Once we got the current, then what is the Vc? They are asking only the amplitude, so no need to worry about the phase. Directly we can go find I and Xc. I multiplied with Xc. So Xc is nothing but 50 here. So 12 by pi into 50. This is the amplitude what we got. So how much you are going to get? 190.98 volts. This is the voltage fundamental component of V. So I am explaining it again. A symmetrical square wave is given as input and they want to calculate voltage across the capacitor, that too fundamental harmonic component. How we can decide it is a fundamental harmonic component? Because fundamental harmonic component frequency is equal to 5000 radians per second and they are also asking the 5000 radians per second. So for that, first we have to see what is the fundamental harmonic component of V of t, because whenever you want output as a fundamental harmonic component, then input must be the fundamental harmonic component. So frequency must be the same. So the fundamental harmonic component of V of t, so there is nothing but n is equal to 1. So 60 by pi cos 5000 t. So it is cos sine, it won't make any difference because finally we are finding out only the amplitude. I hope you understood. So if you assume even square wave or odd square wave, will it make any difference? No, not at all. Why? Because finally they are asking only the amplitude. That's why they haven't mentioned whether it is even or odd. So from that I have taken the liberty and I said it is an even square wave. Is that clear? So if I say it is even square wave, so it is having only cos terms. So this is nothing but the first fundamental harmonic component. For that, correspondingly we will calculate the I value. Once we got the I value, so from that if I multiply the impedance with I, we are going to get the voltage. But here we require only the amplitude, so I can simply multiply with XC. That is nothing but reactance. Then we are going to get the 190.98 volts. Clear? Take it. So let's go back and do the question number 11. So this question was not done. So let's see. Question number 11. A periodic signal x of t periodic signal x of t with the period 2t is given by x of t is equal to 1 or minus 1 minus t by 4 less than t less than 3t by 4 3t by 4 less than t less than 7t by 4 less than 7t by 4. Which among the following gives the fundamental Fourier term? Which among the following gives the fundamental Fourier term? Of x of t. Options: 4 by pi cos pi t by capital T minus pi by 4. Option B, pi by 4 cos pi t by 2t plus pi by 4. Option C, 4 by pi sin pi t by t minus pi by 4. Option D, 4 by pi sin pi t by 2t plus pi by 4. Which option is going to be correct? Okay. First, try to draw x of t so that you can get insight. X of t. Minus t by 4 to 3t by 4. Let's say minus t by 4. Let's call it as 3t by 4. Between that, its value is equal to 1. Next, between 3t by 4 and 7t by 4. the value is minus 1. Minus 1. 1 minus 1. This is the wave which is a periodic. So what is the total period? 7t by 4 minus of minus t by 4, which is nothing but 8t by 4, which is nothing but 2t. That's what it is. Period is 2t. Now it is not a symmetric. That means it is not even, it is not odd. So we don't have any formulas for this. Let's say let y of t, which is a symmetric kind of thing. That means, let's say if I shift it, so let's take a shifting. One minus 1, 0. This is t, this is 2t. This is the kind of wave. Now it is what we know. Actually, this is going to be, suppose if I extend it, so it is going to be like this remaining. So this is the kind of wave we are going to get. So it is nothing but odd and half wave symmetry. So in this we don't have any symmetry. But what is the relation between y of t and x of t? That means what we have to do with y of t so that I can get x of t. If I shift y of t in the left side direction by t by 4, then we are going to get the x of t. That means we have to advance this y of t by t by 4. Clear? So that we can get the x of t. So I can write x of t is equal to y of t plus t by 4. That's what we have to do. Clear? Now let's say, for this, what is the fundamental harmonic component? If you know the fundamental harmonic component for y of t, if you advance by t by 4, we are going to get the x of t. Now, first you tell me, what is the symmetry present in y of t? It is odd plus half wave. Odd plus half wave. If it is odd plus half wave, what kind of terms it is having? Only odd sign terms. Odd sign terms. Odd sign terms. Now, if it is having only odd sign terms, can you tell me fundamental harmonic component or first harmonic component of y of t? First harmonic component of y of t. That is, let's call it is y1 of t. Y1 of t. So what is that? For this, we are having Bn, which is nothing but 2 into maximum value minus minimum value by n pi. That is 4 by n pi. So fundamental harmonic component means this n value is equal to 1. So 4 by pi sine, what is the omega naught value? Omega naught is equal to 2 pi by period, that is 2t, that is pi by t. Pi by t. So sine pi by t into t. So this is what the fundamental component of y1 of t. So once we know the fundamental component of y1 of t, can you find out fundamental component of x1 of x of t? That is first harmonic component of x of t. That is x1 of t is equal to y1 of t plus t by 4. So in place of t, we have to place t plus t by 4. Then what will happen? 4 by pi sine pi by capital T, wherever t is there, that is replaced with t plus t by 4. Then finally 4 by pi sine pi t by capital T, tt get cancelled, pi by 4. So this is what we got. So if you observe the answers, which is not visible. So many people think that option D is correct. So our brain in the examination will say, suppose which is a similar kind of answer, if you see that, that is going to be the correct. That's what we are thinking. But that is not the correct answer, because here it is 2t is there, here we are having t. So most people think that, the students' mind will say that, okay, we may have done somewhere some mistake, so that we got the something which is the wrong answer. So most probably D is the answer. That's what we are thinking, but that's not the correct. Actually, the answer is can you convert this into cos? So if I do that, if I convert this into cos, 4 by pi sine pi, sorry, cos pi t by t plus pi by 4 minus pi by 2 minus pi by 2. Finally, this is 4 by pi cos pi t by t minus pi by 4 minus pi by 4. Answer is A. So be careful. So if you do any manipulations, you may get one of the answer. Don't go with a similar kind of answer. So the first what we got is this one. So it looks very similar to this answer, but this is not the correct answer. So it is having 2t. So to get this answer, we have to manipulate it into cos term. Clear? Take it. Next question. Question number 14. X of t is a real valued function of a real variable with a period t. It's a trigonometric Fourier series expansion. It's trigonometric Fourier series expansion contains no terms of frequencies omega is equal to 2 pi by t into 2k, where k is equal to 1, 2, 3 and so on. Also, it does not contain any sine term. Then x of t satisfy the equation. Then x of t satisfy the equation option A. X of t is equal to minus x of t minus capital T. Option B. X of t is equal to x of capital T minus t. Option C. X of t is equal to x of t minus t is equal to minus x of t minus t by 2. Option D. X of t is equal to x of t minus t is equal to x of t minus t by 2. First read the question so that you can get the answer. So x of t is a periodic function with a period t. So with the period t means, can we write x of t plus or minus t is equal to x of t? This is the first thing we can write. So any periodic signal, if you move a period, then you are going to get the same signal. Its trigonometric Fourier series expansion contain no terms of frequency like this. So these kind of frequencies are not present. What do you mean by that? These kind of frequencies are not present. So try to understand. What are these kind of frequencies means? 2 pi by t, that is nothing but omega naught into 2k, where k is equal to 1 to 3. That means it is a even multiple of frequencies, even multiple of harmonic, first harmonic, that means even harmonics. So we don't have any even harmonics. That's what the meaning of it. So if it is does not having any even harmonics, that means it contains only odd harmonics. Then what kind of symmetry it is exhibiting? Half wave symmetry. So from the second point we can say no even harmonics. No even harmonics. This is the first point they said with period, and this is the second point they said don't have any frequencies which are even harmonics. So if it does not have any even harmonics, that means half wave symmetry. Half wave symmetry. If it is exhibiting half wave symmetry, then can I write like this? X of t plus or minus t by 2. If you move half of the period, if it is a half wave symmetry, we have to get minus x of t. Minus x of t. This is the one thing. Next, it does not contain any sine term. It does not contain any sine term. So this is the third point. So if it does not contain any sine term, so what is that supposed to mean? It is having even symmetry or odd symmetry. It is having only cos terms. If it is having only cos terms, that is having only even symmetry. So third point, no sine term. It implies even harmonics. So sorry, even symmetry. That implies even symmetry. If it is even symmetry, we know that x of minus t is equal to x of t. By combining all them, then which option is going to be correct? That is option C. Let's see how. First of all, x of t, x of minus t. By combining 1 and 2, by combining 1 and 2, what we can write? X of minus t. If t is replaced with minus t, so it is minus t plus t, let's call it is only if I take plus t, is equal to x of minus t, which is nothing but x of t. So from this we can say yes. So by substituting here. So what is x of t? X of t is equal to x of capital T minus t is equal to x of t. If I take this minus here, so it is minus x of t minus t by 2. I hope you understood. I am combining third and first. X of minus t is equal to x of t. So if I replace t with minus t on both sides, then this is going to be x of minus t is equal to x of t only. And if I replace t with minus t, if I take only positive, then it is plus t. I hope you understood. So this is what the expression we get, which is nothing but C. Clear? Take it. One by 4 period of a periodic waveform is shown. That means they have given only quarter period. 0, t by 4. 1. Okay. So given 1 by 4 period. 1 by 4 period. First question. If x of t contains only odd sine terms, then draw a full period. In the similar way, second question, if x of t contains only odd cosine terms, cosine terms. Then draw full period. Then draw full period. So given only quarter period, then we have to draw the full period. How we can do this? Okay, listen. So if the signal contain only odd sine terms, if it is contain only odd sine terms, then what kind of symmetry it is exhibiting? First, odd symmetry. Why it is odd symmetry? Because sine terms, and that too only odd sine terms, odd harmonics. That means it is having half wave symmetry also. So a wave is exhibiting both odd and half wave symmetry. How we can draw this? Let's see. I will consider full period 0, t by 4, t by 2, minus t by 4, and minus t by 2. So minus t by 2 to plus t by 2, that is nothing but total period. Minus t by 2 to plus t by 2, total period. Question is, draw the waveform for full period. So given, this is the one. So this is what they have given. Now let's see. If it is satisfying odd symmetry, if I fold it, we have to get the negative. So from this odd symmetry, what I am doing, if I fold it, I have to get the negative. To get the negative value, so here what it has to be? It has to be in the negative direction. So this is what we have to get. Next, because it is half wave symmetry, if I shift it half period, then we have to get again negative. So half period, if I shift it, this part will go here, this part will go here. So for that it has to be negative. So this is what we are going to get. This is what we are going to get. Next, again it is a odd symmetry. So for that we must have this kind of wave. Now let's check it out. Is it satisfying odd and half wave? If I fold this, I am going to get the negative. Yes. If I take total period, half period has to be same with the negative sign. Yes. This is satisfying odd and half wave symmetry. Clear. Next, coming to this one. Odd cosine terms. If it is having odd cosine term, what kind of symmetry it is exhibiting? It is even plus half wave. Even plus half wave. How, sir? Cosine terms means even. Odd means half wave, because odd cosine term is odd harmonics, that means half wave symmetry. So we have to draw total period by making sure that it has to be even symmetry and half wave symmetry. So let's see how we can draw this. Again I will take the period is from minus t by 2 to plus t by 2. 0, t by 2, sorry, t by 4, t by 2. Minus t by 4, minus t by 2, minus t by 2. This is the wave 1. Even symmetry, that means if I fold it, we have to get the same thing. So that means it must have this kind of wave. Next, half wave symmetry, that means if I shift this half period, this part will comes here. That must be negative value. So this is what it is going to be. So again it is even symmetry, whatever there, it has to be continuing here also. Now check it out. Is it having the even plus half wave symmetry or not? Let's see. If I fold it, we are going to get the same thing. And is it having half wave symmetry? Yes. Whatever we are having, the same thing we are having here also, but with a negative sign. I hope you understood. If a quarter period is given and they have given some conditions, based on these conditions, how we can draw the remaining total period. Okay. Take down.